you're going.
All right, good evening. I'm Mr. Wiegand. Eventually we're going to have Mr. Shell show up. What we're going to do today is introduce the concept of weakly interacting gases. Whereas what we've done most of the semester was the ideal gas, which gets boring because all it has is kinetic energy. There's no need to involve potential energy. What we're going to do today is we're going to actually evaluate the partition function for an interacting gas. So we're going to start off calling our partition function Z1 for one particle is 1 over h cubed times the integral d3r d3p times e to the minus beta e, where e is the total energy of the single particle. And it's evaluated, the integral is evaluated over its position vectors and its momentum vectors. So what we're going to do now is we're going to take this to n particles. What we're going to have to do is add in a factor of n factorial here. So now there will also be n factors of h cubed. And then we'll have d31 all the way up to d3rn. And the same with the momentums. We'll change this E to U, which we'll call U to be the total energy of the system. And we'll stop there. Here's this. I need a razor. So now we're at kinetic energy stuff. Okay. So now we know that the total energy of the system is equal to kinetic energy plus the potential energy from Physics 271. We know the kinetic energy of n particles is just, let me erase this again, and get that the kinetic energy is the momentum squared of particle 1 over its mass plus the momentum squared of particle 2 times its mass, or over twice its mass, all the way up to the nth particle. Which means that we can now rewrite our partition function. Z is equal to 1 over n factorial, 1 over h to the 3 to the n, integral, all our d's will times e to the minus beta pi squared over 2m times e to the minus beta u potential, where I is just the index for which particle we're integrating over. And we've evaluated the integral for the momentum previously in class to be equal to integral for the momentum is root 2 pi mkt.